So even though they don't tell you what f of x is in this problem, you can still find the derivative that is y prime or dy by dx, whatever notation you want to use. And it's still going to come down to the product rule. Now the product rule tells me I want f prime times g plus g prime times f. So what's that going to look like? Well, let me lay things out. F is just f of x. G is x squared. F prime is just going to be f prime of x. G prime, maybe somebody can help me out. What's g prime going to equal?
2x.
Yeah, 2x. So filling this in, this is going to be f prime of x times x squared plus 2x, which is your g prime, times f of x. And that's your derivative. Let me do another one kind of like that. You know what? I have to wait until we do the quotient rule. So, are we okay with this one? Now, a lot of times what they'll do is they'll give you values for f at particular points. They might tell you that f of 3 equals 6, and then f prime of 3 equals -4. And if that's the case, then you should be able to evaluate y prime at, say, x equals 3 and get an actual number. Because you could put in these values into f and f prime, and then you can substitute directly in for your functions of x. But we'll do one like that in a little bit. So I like this one because photo math will choke on this one. It's a good one. Well, let's see what's going on here. And we'll actually work with q of x. Q of x is going to require us to use the quotient rule, and that's what we're practicing right now. So let's take a look here. Q of x is f of x divided by g of x. And we're going to be asked to find some stuff about the derivatives. So let me remind you about the derivative of q of x. So q prime of x, this is just your basic quotient rule. You're going to square the denominator, and then it's going to be the denominator times the derivative of the numerator, so f prime of x, minus the numerator, f of x, times the derivative of the denominator. So it's not till you get to this last term do you finally start working with the derivative here. Now in this problem, they ask us for the derivative at x equal 2. So I want to find, pardon me, x equals 7. So I want to find the derivative at that point. So let's kind of fill things in a little bit and see what they use. So I want q prime of 7 is going to be g of 7 times f prime of 7 minus f of 7 times g prime of 7 all over g of 7 squared. To fill this in, there's four things I need to know, and I'll list them for us. I need to know f of 7, f prime of 7, g of 7, and g prime of 7. Now, a couple of these are just going to be evaluating the function at these points. So let me do that. We'll start with f of 7. So up here, here's f of 7. F of 7 is what? Anyone?
5.
Yeah, f of 7 is 5. And in a similar way, g of 7 is 1. But now we got to think of the derivatives. And they did something nice for you in this. And that is that they made the derivatives pretty simple. So let's see if we can't calculate the derivatives. Now, the derivative is going to be the slope of the tangent line. But because f is increasing at a steady rate past x equals 3, it's just this nice constant rate. The value of the derivative anywhere here in this green line is just going to be the slope of that line. Can anyone suggest how I can get the slope of that line? Well, I think of slope as rise over run. That's my favorite way to think about slope. So if I go over this far horizontally, then I've got to go up this far vertically. In other words, my rise over run gives me what ratio?
A quarter.
Yeah, 1/4. So m equals 1 divided by 4. Nice. I've got to do the same thing down here for g. So we'll start here at a convenient point right here at 3 and 4. And if I go down, say 2, how far over do I have to go?
3.
3. Now the slope isn't 2/3. What is it?
Negative 2/3.
Negative 2/3. Good, because you're going down, so the rise part is negative. So great. So this is what you should be getting from that picture. And I'll pause here for a second. If there's something that, like, wait a minute, that went too fast, let's get some help, because this is a good problem, not only for your homework, but for your review. Let's fill in everything in here. So g of 7 is a 1 times f prime of 7, which is 1/4, minus f of 7, which is 5, times g prime of 7, which is negative 2/3, divided by g prime squared, which is negative 2/3 squared. I'm just going to do that on my calculator, make it do all the heavy lifting. So I'll start by hitting that alpha key and then the y equals key, like I did earlier. If you don't have this key, that's fine. Just do parentheses around the entire numerator.
Sorry, real quick. Is the denominator supposed to be just G7, not G prime?
Oh, you know what? You're right. Thank you. That's going to make it easier. Thank you. That's a good catch. That's going to be 1 squared. Ha, I'll do that one without a calculator. How about that? Woohoo! So this is going to be really, let's do this a little bit by hand first. That's going to be 1/4 plus 10/3. Now, if you're not in the mood to do this in your head, that's fine. Let's do 1/4 as 0.25 plus 10 divided by 3 is going to give me a big mess. But then you hit the math key, answer the fraction, and you get 43/12. You want to do this because chances are they're not going to be asking you for a decimal answer. That's the only time you're going to type in decimals. If they tell you to solve this, they're looking for an exact answer, not an approximation. So there was one in the homework that ended up as E minus 1, and the correct answer was E minus 1, not 1.7281828, etc. So just be careful. If they want a decimal, they'll ask you for a decimal. All right, that was a good one. That was a real good one. Comments or thoughts on that one? I like it for a couple reasons. One is that, you know, there's not a whole lot of ugly calculations. And two, it really makes you know the quotient rule and understand what derivatives are. Those derivatives are just telling you the slope of the tangent line, and you're gonna have to calculate it based on the graph. Now, if we're looking at something for which we're calculating the derivative of f at 2, what would the derivative of f of 2 be? F prime of 2, what would that one equal?
0.
0, yeah, because you've got a horizontal tangent line here. To the left of that point, your derivative is decreasing, so it would be negative, and then to the right of it, it's positive. One other question here. Do you think the derivative would exist for f at x equal 3?
No.
No. Cool, because you got a corner point. How about for g? Where is g going to have a derivative that won't exist?
At 4.
At 4. Good. So again, you've got a corner point there. Excellent. Excellent. So we're going to find the equation of the tangent line to this function at this point. Since we've got the point, the only thing left that we need to know is m, which is the slope of the tangent line. And the slope of the tangent line comes from the derivative. And that's going to mean the quotient rule. Now, for one last time, I'll set it up like this. And I'm going to need an f prime and g prime. So, Nina, you out there? What would f prime be, please? Or maybe Sandy. Sandy, can you help us? What are the derivatives of these functions? F.
I think 1.
Good, 1.
And for g, e of x.
Perfect. There's our derivatives. Nice and simple. Let's put those in and calculate the derivative for this, at least the nice general expression for it. F prime, or f divided by g prime, square the denominator times the derivative of the numerator, and the numerator times the derivative of the denominator. So piecing all those things in, and thank you, Sandy, that's going to be 1 plus e to the x squared, and 1 plus e to the x times f prime, which is 1, minus f, which is 1 plus x, times g prime, e to the x. And, you know, it's kind of up to you how much you want to simplify it. It does simplify down a little bit. You know, I don't know how much effort you want to spend in doing that. What we need out of this is we need to evaluate this at x equals 0, because that's our y prime. That tells me the slope of the tangent line everywhere. I probably should set a good example, clean it up a little bit. If I distribute everything, 1 plus e to the x minus e to the x minus x e to the x over 1 plus e to the x squared gives me something like that. And now I'm ready to find the equation of the tangent line, or the slope of the tangent line. I probably should simplify something first, though. Does anyone see it? Something that'll simplify?
E to the x minus e to the x.
Yeah, those cancel. So I'm left with 1 minus x e to the x over 1 plus e to the x squared. That tells me the slope of the tangent line anywhere. Where do I want to find the slope of the tangent line?
At x equals 0.
At x equals 0. So the notation that I like to use is this. I'll put a little bar down here, x equals 0. So it means I'm plugging in x equals 0 into this expression. 1 minus 0 times e to the 0 over 1 plus e to the 0 squared. Turns into 1/4.
I think.
Yeah, your work camera is frozen.
Oh. There
Oh,
we go.
there you go.
Thank you. So here's a notation I like to use. Y prime evaluated at x equals 0. So it's just plugging in x equals 0 into my expression for y prime. Gives me 1 minus 0 times e to the 0 over 1 plus e to the 0 squared. And that turns into 1/4. So that's my slope of the tangent line. If I pair that together with this point, I get y minus 1/2 equals 1/4 times x minus 0. So the equation of the tangent line should be y equals 1/4 x plus 1/2. So if I were to graph all this, I should get a nice tangent line right there. Here's my function. Here's the point. How come it's not showing? There it is, right there. And then here's the equation of the tangent line. Beautiful. Okay, comments or thoughts on that one? Doing good?
What is the equation called that we plug in the slope to? The y minus,
y1 equals m times x minus x1. That's called the point slope form of the equation of a line.
okay.
So kind of a big $10 word there. I'm never going to ask you what the equation is called, but certainly we use it a lot. My son's calc teacher would always just plug in the point and then solve for things using this equation, the point slope form of the equation of a line.
This seems kind of
Or the
silly.
slope intercept form. I don't like it. He got used to it, so when he would do it, it just used to drive me crazy, but it works. So I'm not going to dictate how you have to do it, but you are going to need to find the equation of the line somehow. Yeah. So thanks for asking. All right, we'll call it a session on this one, and I'll let you free here in just a second.